Hello, my name is Greg Gagne. I'm one of the co-authors of the 8th edition of Operating System Concepts. In this video, I'd like to demonstrate one of a set of simulators we provide with the 8th edition. This simulator was written by Steve Robbins of the University of Texas, San Antonio, and demonstrates the translation of logical to physical addresses. Here's our zip file. When we extract it, it produces a folder named address. This folder has a couple of different run options. For Windows systems, you merely double-click the batch file. I'm running this on a Mac, so I'm going to open up a terminal window in this address folder. I'm going to click Run Address. I'm going to choose the command Run Address. The simulator opens up, and there are several different tests. There are 5 different tests for performing single-level page table address translation. In 2-level address translation, there's 7 different tests. We're going to begin with demonstrating a few tests of single-level address translation. We're now going to demonstrate the test for single-level page table address translation. We're going to perform test 2. Several different windows appear with this simulator. With test 2, we can see that we have one level page table. Our page size is 256 bits. This is our logical address, and we have to translate this logical address to its corresponding physical address. There's a button down here for progress. We're going to click on the progress button. That essentially tells us the steps involved with address translation. Step 1 is that we have to segment the logical address. What we can see with our logical address, which is right over here, the page size is 256 bits. To uniquely reference any word in that page, we'll need 8 bits in our logical address. So we are going to segment our logical address to 8. Note, when we move the cursor, this aqua window up here tells us how many bits we have selected. So we're going to select 8 bits. Note that when we've selected that position, our progress highlights that we have segmented the logical address. We're going to do the same thing with the physical address. Again, 256 bits. And for our page size requires 8 bits in our logical or physical address. I'm going to segment 8. Next, we're going to paste the offset from the logical address into the physical address. Choose the select button. Highlight the offset. We're going to paste it. And note, step 3 in our progress window indicates that we have successfully pasted the offset into the physical address. Step 4 tells us to display the page table memory view. So we're going to click on memory view. This is the contents of the page table for this test. We now have to find the entry in the page table. So we're now going to select the logical page number and our logical address. We're going to go to our memory view, and we're going to look up that entry. And that entry is highlighted. So here is our logical page number. The valid bit is set to 1, which means that this mapping is correct. And there is the corresponding frame for that logical address. Note the contents of a clipboard. The frame has been copied to the clipboard. Our progress window tells us that we have successfully found the entry in the page table. The next step is to paste the frame number into the physical address if valid. So the frame number has been copied to the clipboard. We're going to choose Paste. And we have pasted the frame number into the physical address. We have correctly translated this address, so we'll choose the button Found Physical Address. Little button down here indicates that the correct physical address has been found, and we see over here that we have successfully completed test 2. Next, I'd like to demonstrate address translation using a TLB. For this, we're going to use test 5. I'm going to click the progress window as well to show us what we have to do. Note, with the progress window, these steps now tell us that we have to segment the TLB. So initially we're going to look at the page size, 4096. That'll require 12 bits in both the logical and physical address. We're going to segment those 12. So with that. Next we're going to select the offset and paste it with the physical address. We're going to click on the TLB button. Here's the translation look-aside buffer. The first thing we have to do is segment the TLB. We know that our logical address has 18 bits representing the logical page number. So we're going to segment the TLB from the left, 18 bits. Down here, this mode segment tells us how many bits we've translated. So we're going to go 15, 16, 17, and there's 18. We've now segmented the TLB. I'm going to select the logical page number, and we're going to do a lookup. And we found it. We found the corresponding frame in the TLB. Note that display page table memo view and find entry in the page table, these two are grayed out because we don't have to go to the page table now. We resolved the address translation in the TLB. The corresponding frame has been copied to the clipboard, and we're going to paste the frame into the physical address. And we will choose Found Physical Address. The final test we're going to demonstrate is for two-level paging. The Address Translation Simulator main menu. We're going to click on two levels. We're going to choose Test 5 for this demonstration. Note that our progress window tells us 16 steps, significantly more steps for performing two-level translation than one level. We see our page size is 4096, so we're going to segment the logical and physical address of 12 bits. We're going to copy the offset from the logical into the physical address. Next, we're going to segment the TLB. Our logical address has 18 bits in the logical page number, so we're going to segment the leftmost 18 bits in our TLB. Segment the TLB. We're now going to select the logical page number and do a TLB search. We're going to click on Lookup, and it indicates page not found. So we have a TLB miss. That means that we're going to have to walk the page table. So I'm going to display the memory view. This is the first level of paging. We next need to segment the logical address again. We see that our logical address has 18 bits for the first and second level of paging. However, our second level of paging, our level 2 page table size, is 512 bits. That would require 9 bits in the logical address. So we have to segment the logical address into 9 bits. Next, we're going to select first level page number. We're going to find the entry. We see the valid bit is set to 1, and the frame indicating the second level page table has been copied to the clipboard. We're now going to display the second level page table. And we're going to set the frame number of the second level page table to what is in the clipboard. Now we're going to select the second level page number in our logical address. Click Entry to do a lookup. And our second level page table finds the second level page number mapped to this frame. The valid bit has been set to 1, so we know that is a page table hit. The frame has been copied to the clipboard. We're going to paste the frame to the physical address and click the Found Physical Address button. There are several other tests that we have not covered in this video. Other tests indicate page faults and then invalid references.